Hi, my name is Ben Mock. I work for Siemon and I've had to do a voiceover for this video because the audio from the evening came out terrible. So you can see my details on the screen. I've been involved in BICSI and I'm a cabler by trade. Now, when I mention the word standards update, this is generally the response I get. It's not the most exciting topic. So I will keep this short and sharp and fairly brief and may skip over some items. So hopefully this will wake a few people up. What if you do cabling without a proper license? You can see on the screen here, you can get a $2,000 on the spot fine or $90,000 if it goes to court. And as an organisation, you can be fined up to $10 million as per the Telecommunications Act 1997. So hopefully this will wake a few people up. Now, this is a question I put out to the audience there where I said, what's the purpose of a standard? There was a couple of responses there. You can see the microphones being run to the back there, and I think they said consistency. So I bring up firstly the ISO definition, which says, requirements, specifications, guidelines. A standard is an agreed way of doing something and the minimal level of acceptable performance. Now, the most important point, I think, with a standard is we call it CYA. I referred to the audience and asked them CYA stood for cover your assets, but it is to define a defendable position when things go wrong. We know standards are never perfect. There's always the new standards come out, amendments, then a revision, and then back to new standards. So we know that they constantly evolve. So before I get into it, I always bring up this disclaimer. Look, I've tried to make everything correct. This is just my interpretation of it. And if I get it wrong, please don't sue us. So a couple of things we need to know about some standards that are coming up. First up, we've got the ISO 11801 standards that has replaced AS 3080. The Australian MPTL has been added to these standards as well as defining the testing requirements. And the MPTL is basically a patch panel with a plug on the end, typically used for cameras and WAPs. There's a new standard that came out 2020 called AS 14763-2, and this is dealing with implementation and operation of customer premises with 3 ratings, RP1, RP2 and RP3, to do with remote power and how we address heat rise. And the 90 metres may need to be shortened to address this. Also in the 14763-2 is DC resistance unbalanced. Now the main aim with this is to deliver power over comms. We're talking 100 watts, so half an amp per conductor, or 1 amp per pair, and we will see the cable take a little bit of heat. If we get it wrong, there can be a DC resistance unbalance within the pair or between pairs, and it may flood the balance at the end. And finally, we've got the 11801-6, which has a minimum requirement of Cat 6A. So, as an industry, we generally agree on this: 90 metres permanent link and 100 metres channel, 5 metres either side with patch cords. So, what standards say about temperature with this is it assumes the ambient temperature is 20 degrees. Now, we know that it will get well above 20 degrees in certain installations. So, can it get hotter than 20 in the real world? Absolutely. Is temperature an issue? So depending where the cables are installed, we know in the roof space it can easily exceed 50 degrees depending on the bundle size and the size of the cable. What about data centers and hot areas? Then we talk about putting PoE down the cable as well. Currently there's no method to cool down hot pathways, and also we don't know what level of power is running through the cables. So this graph here shows the D rating that is required for cabling. So you can see the red line there is a Cat 6A UTP. At 60 degrees, the cable would need to be D-rated by 18 metres. Then you can see the dark blue line for a Category 6A F UTP, and still at 60 degrees, there needs to be a D rating of 7 metres. So the point I try and get across here is length of the cable matters, size of the bundles, size of the cable matters, and temperature matters. And they're probably the three main aspects that are factors that we need to consider when we're talking about PoE. So this is a summary of all the key changes. There's a lot there, and I will go through some of the key ones in a little bit more detail through this presentation. So the first one that I bring up is S008 and S009 are safety standards. So we know with changes in technology, there is a higher dependency on health and safety through the cabling system, with emergency telephone calls, assisted living areas in hospitals, life dependency and safety dependency. Standards are starting to address this. They've also added the fitness for purpose clause in here. S009 is also a safety standard, and this is new classifications introduced for ES1, ES2 and ES3, which is replacing the ELV and SELV terminology, and also fitness for purpose clause was added. In 2020, standards introduced DC resistance unbalance as a requirement for the internal transmission and has added additional testing. Fluke testers, along with other brands, have the ability to do DC resistance unbalance testing as a standard feature, and it adds a couple of seconds onto the test. So what happens if we get the imbalance wrong? In this picture here, if the top one has high resistance and the other conductor is low resistance, then more power will go down the low resistance, which unbalances the cable. We can get more heat rise where the unbalance is. It's more prone to noise as it gets higher imbalance, higher attenuation, and we get an increase in signal loss. And the other thing is, if the voltage is too high, we flood the balance at the end, and we may not be able to pull the data out. And additionally, devices then start trying to protect themselves by shutting down the power, so then we can have unreliable devices at the end. It's not a big cause for concern, but we just need to know what to look for. So we're also dealing now with something called RP1, RP2 and RP3, and this is remote powering and how we deal with the heat rise within cables. Some of the key factors to consider is the size of the bundle, where the cables are installed, free in the air or is it in conduit or duct, how many conductors are being used, what level of power they are actually carrying, and is it constantly on or just sometimes on. So this is to support remote powering up to 100 watts, and the AS 14763-2 gives us a lot of information of how it relates to heat rise within cables. Next, in S008 and S009, there's the ES1, ES2 and ES3. So put simply, ES1 and ES2 are basically safe. You're not going to die from touching it. It may hurt you, but you won't die. ES3, however, has no voltage or current limit specified, so standards are saying this is a dangerous cable. Standards haven't applied any requirements to the cable, except they now want you to have a special colour, Homebush Gold, with Homebush Red markings with it, and most manufacturers aren't going to make this cable, with the intent that this cable ES3 won't be used. So a couple of other key changes is there is a minimum size for cable or maximum conductor size, and as I said earlier, the main points I want to get across with this presentation is length of the cable matters, size of the bundle, size of the cable matters, and temperature matters. As I said, they are the three main points that I try and get across here. The fitness for purpose clause has been added to both S008 and S009. Basically says cabling products to be selected and installed, they need to be fit for the purpose they are intended for. So in May 2019, IS 11801's Part 1 to 6 replaced AS 3080. So you can see Part 1 was generic cabling, and then Parts 2 to 6 was cabling for specific applications. You can see here the list of them, And most importantly, I point down to the bottom one, which is part 6, distributed building services, which has got a minimum class of EA or category 6A that has been specified for this. For consultants, you'll have an account with SAI Global. You are able to purchase the standards. Make sure you get the up-to-date ones. So referring to part 6 again, the distributed building services, it's aimed at supporting IoT applications. You can see there it's also there to incorporate the supply of power. It is in the intelligent building services sector, and class EA is the minimum requirement that we put in there. And it said this is to really address your WAPs and cameras. This is a picture that was taken at an airport. You can see the picture on the left there. The patch cords are visible. Now this is at reachable height. Somebody could jump up and unplug that patch cord, which could pose a security risk. So the picture on the right is what we're aiming for, where you cannot see any cables and it's all in behind the wall part of the device. So ISO 11801 has also introduced an Australian MPTL. What I'll try and get across here is there is now a test for it in your Fluke and other brands. Just look for AS/NZS MPTL and then pick the right test. So remember, these new standards have all been ratified. Referring to old editions can be really bad. If you are writing specs, make sure you call up the correct editions and avoid conflicting ones. Get familiar with them. If you are responding to cable specs, check that the correct ones are being quoted and you are up to date. So the final takeaways for the evening is part 6 in distributed building services, minimum performance of class EA or category 6A. So that is to support your WAPs, cameras, IoT, and supply power through there. AS 14763-2 is to do with your power through the cable. And as I said, length, size, and temperature are the key factors there. Cabling standards supports PoE and has outlined testing requirements for it. So make sure you stay up to date with the current versions and use quality cable and connectors. So I'll leave the presentation with this slide where if clients say find something cheaper. So thank you very much for your attention. Here are my details.